Hello students, in this type we have to see how to take derivatives of composite function. It is commonly known as chain rule. It is commonly known as chain rule. Assume two functions sin x and log x. This is a trigonometric function, this is logarithmic function. If we combined these functions such as sine of log x or log of sin x, then on variable x there are two functions applied. First is sine and other is log. Then sine is called as outer function, log is called as inner function. If we going towards x, sine is the first function which is outer function, log is the second function which is inner function. And in another way we can write log of sin x. If we going towards x, log is the outer function, sine is the inner function. Take another example, root x and tan x. If we write root of tan x, then if we going towards x, root is the outer function, tan is the inner function, or a tan of root x. Tan is the outer function, root is the inner function. Now find dy by dx for the following. Find dy by dx for the following. Y is equal to sine of log x. Differentiate with respect to x. Derivative of y with respect to x, dy by dx. Now see here, if we going towards x, outer function is sine and inner function is log. If we going towards x, outer function is sine, inner function is log. Only consider outer function, that is sine. Write here as sine fx, sine of some term. We know that derivative of sine x is equal to cos x. Derivative of sine some term is cos of that term into derivative of this term, write in numerator. Derivative of this term, write in numerator. Therefore, derivative of sine some term is cos of that term into derivative of this term, write in numerator. Derivative of log x, write in numerator. Derivative of log x, 1 upon x. Therefore, cos of log x into 1, cos of log x upon x. Second problem is y is equal to cos of log x. Y is equal to cos of log x. Differentiate with respect to s, dy by dx. See here, if we going towards x, outer function is cos, inner function is log. Consider only outer function, that is cos of f of x. Derivative of cos x minus sin x, derivative of cos fx minus sin fx into derivative of fx, write in numerator. Derivative of cos some term minus sin of that term into derivative of this term, write in numerator. Derivative of cos of log x minus sin of log x into derivative of log x, write in numerator. Or assume derivative of cos theta minus sin theta into derivative of theta, write in numerator. Derivative of log x, 1 upon x, minus sin of log x into 1 minus sin of log x upon x is the answer. Next, y is equal to log of sin x. Differentiate with respect to x, derivative of y, dy by dx. If we going towards x, first function is log and second function is sine. Therefore, outer function is log and inner function is sine. We know that first we take the derivative of outer function. Therefore, write the outer function log fx. Derivative of log x, 1 upon x. Derivative of log fx, 1 upon that fx into derivative of this fx, write in numerator. Therefore, derivative of log of sin x is a 1 upon a sin x into derivative of sin x, write in numerator. Derivative of log fx, 1 upon that fx into derivative of this fx, write in numerator. Derivative of sin x is equal to cos x into 1 cos x upon a sin x. Cos x upon a sin x is cot x. Cos upon a sin is equal to cot. Y is equal to log of cos x. Differentiate with respect to x. Outer function log, inner function cos. First take derivative of log. Derivative of log fx, 1 upon that fx into derivative of fx in numerator. Derivative of log cos x, 1 upon cos x into derivative of cos x in numerator. Derivative of cos x minus sin x into 1 minus sin x upon cos x. Taking minus sign outside, sin upon cos is equal to tan. Therefore, answer is tan x. Y is equal to log of sec x. Differentiate dy by dx. Derivative of log some term, 1 upon that term, 1 upon sec x into derivative of sec x in numerator. Derivative of sec x tan x into 1 sec x tan x upon sec x. Now sec x get cancelled, dy by dx is equal to tan x. Y is equal to log of 1 plus x square, differentiate dy by dx, derivative of log fx, 1 upon that fx, 1 upon 1 plus x square into derivative of this fx, write in numerator. Derivative of 1 plus x square in numerator. We know that derivative of constant is equal to 0, derivative of 1 is equal to 0, plus derivative of x raised to n, n into x raised to n minus 1, 2 into x raised to 2 minus 1, 1. Now 2x raised to 1 is 2x, 0 plus 2x is 2x, 2x into 1, 2x upon 1 plus x square is the answer. Y is equal to log of sec x plus tan x. When we consider this function differentiate dy by dx, there is a outer function log and inner term is sec x plus tan x. Means outer function is log and this whole term is the inner term. Derivative of log x 1 upon x, derivative of log fx 1 upon that fx, 1 upon sec x plus tan x into derivative of sec x plus tan x, write in numerator. We know that derivative of sec x tan x, derivative of tan x sec square x. Therefore, sec x tan x plus sec square x into 1 sec x tan x plus sec square x. Now taking sec x common, in bracket tan x plus sec x upon sec x plus tan x. We know that sec plus tan means tan plus sec. Therefore, brackets are cancelled. Answer is dy by dx is equal to sec x. Now the next question, y is equal to sine cube x. Y is equal to sine cube x. This is the difficult function in chain rule. First we have to write y as sin x bracket cube. This is the short form. Sin x bracket cube is the actual function. Differentiate with respect to s, derivative of y dy by dx. Look here, if we going towards x, the nearby function of x is sine. The close function to x is a sine. Therefore, sine is the inner function and cube is applied on sine. Cube is applied on sine. Cube is the outer function. Therefore, outer function is cube and inner function is sine. Inner function is sine. Now differentiate with respect to x. Derivative of fx raised to 3, such type of function. Look here, d by dx of fx raised to n, derivative of x raised to n, n into x raised to n minus 1, derivative of fx raised to 3, 3 into fx raised to 3 minus 1 into derivative of fx, write in numerator. Derivative of sin x raised to 3 is 3 into sin x raised to 3 minus 1 into derivative of sin x in numerator, that is cos x, 3 minus 1 2, 3 sin square x into cos x. Sin x, sin is the inner function, cube is the outer function. Therefore, first we have to take derivative of cubing function, that is derivative of fx raised to n. Derivative of sin x raised to 3, 3 into sin x raised to 3 minus 1 into derivative of sin x in numerator, that is cos x. Therefore, answer is 3 sin square x into cos x. Y is equal to cos square x. Y is equal to cos square x. First we have to write y is equal to cos x bracket square. Differentiate with respect to x, derivative of y dy by dx. If we consider the variable x, the nearby function, the close function to x is cos. Therefore, 2 is the outer function. Raised to n is the outer function. D by dx of fx raised to n, n into fx raised to n minus 1 into derivative of fx, write in numerator. Derivative of cos x raised to 2, 2 into cos x raised to 2 minus 1 into derivative of cos x in numerator. Derivative of cos x minus sin x, 2 minus 1, 1. Taking minus sign outside, minus 2 cos x into sin x is the answer. Cos is the inner function, 2 is the outer function. Derivative of fx raised to 2, 2 into fx raised to 2 minus 1, 2 into cos x raised to 2 minus 1 into derivative of cos x, write in numerator. Therefore, answer is minus 2 cos x into sin x. Thank you, students.